So my 5 photo story is actually going to be kind of a lesson for earth science. And we're going to start off with the layers of the earth. And if you take a look here, you can see that the earth kind of resembles like a jawbreaker, or, a lot of times we'll use an apple or even a hard-boiled egg to represent the layers of the earth. And the main layers of the earth are the crust, the mantle, and the core. Now, of course, the core is split into the inner core and the outer core. The outer core is liquid. The mantle is solid, but it tends to act more like, kind of like, I always call it like Laffy Taffy or taffy when you're stretching the taffy, and it's kind of malleable. It's still solid, but it can move around in things. And then the crust itself, and actually we're going to talk about specifically how the crust, there's oceanic crust and continental crust, but the crust and then just a few miles of the upper mantle make up what's called the lithosphere. And the lithosphere is actually what makes up the plates of our planet. So you can see that the lithospheric plates are kind of like a jigsaw puzzle. And our crust, or well, I guess our lithosphere, is completely made up of all these different pieces. Some are big, some are small. And where the plates meet, we call that a plate boundary. And sometimes the plates at certain boundaries actually move toward each other, and we call that a convergent boundary. Some plates, they actually move away from each other, and we call that a divergent boundary. And then we even have some plates that actually move away from each other in opposite directions. So one could be moving up and one could be moving down, so they kind of slide past each other, and we call that a transform boundary. And that kind of brings us to so the kids think it's pretty fascinating that plates actually make our continents once upon a time move, and actually at one time, and actually scientists actually think that this may have happened at least 3 times in the Earth's history. Because of how the plates have moved, but it has actually moved all of our continents in so many different directions together at one time. Our huge continents were actually together into that we call big supercontinent, and we called that supercontinent Pangaea. So getting back to the different boundaries at the plates, one of the plates we talked about was, or one of the boundaries we talked about was actually a convergent boundary. And off of the coast of Washington, the west coast, we actually do have a convergent boundary in that area. And what happens is we actually have the Juan de Fuca plate is an oceanic plate that actually subducts, it gets pushed down underneath the North American plate. And as that material gets pushed down with the movement and everything, then what is created are these magma chambers. And, they're always pushing material up. And so this Cascade Range has been formed, and it's actually full of volcanoes in that area. And of course, the most famous of those volcanoes is Mount St. Helens. Now, I remember the one of the big blast in my lifetime that Mount St. Helens had, and that actually happened in 1980. And I was about 5 years old, and I remember living in Idaho. I mean, I was a long ways away from Mount St. Helens, but I remember having to wear a mask over my face, especially over my nose and mouth, because the air outside was so full of ash that we couldn't breathe outside. So this picture was actually done by a photographer, and you can see that on the left-hand side, this is actually a pre-1980 picture, and you can see, how tall Mount St. Helens was, where the cone is at, with all the snow on it and everything. And then after 1980, you can totally see where, almost like a whole entire side of Mount St. Helens just disappeared, and it lost a huge part of its cone. And this is a more recent picture of Mount St. Helens. And, a lot of people don't think about, when they think of Mount St. Helens, they think of that big 1980 blast. And actually, there were lots of little eruptions after that, lots of earthquakes after that. And it actually had lots of activity for several years after that. And then it did go through another series of minor eruptions that where ash was spewed out, steam and other particles in 2004, and it was several months where it was still spewing out stuff. And even today, you can see that magma is still building inside Mount St. Helens, and this magma dome here continues to get bigger and bigger all the time. They actually even have live cams up on Mount St. Helens, and on a clear day, you can see into the volcano, and you can see the steam rising from it. I mean, it's still hot and it's still very much alive. So that's the future of volcanology, or as a volcanologist at Mount St. Helens is, trying to predict when is it going to have more activity, when will it erupt again, and if it does erupt, will it be as big as it was in 1980?